You are listening to Explain Science, a part of the Grant podcast. My name is Niels Winter, and I'm the creator, editor, and host of The Grant. The Grant is an independent podcast initiative with the ambition to dig into all corners of the EU R&D funding system on topics of interest for the full EU R&D funding community. Welcome to Explain Science. This is the first episode in my new science communication format. I always wanted to add this to my podcast flow, and after several requests from contacts, here it is. Explain Science will fold out the innovation and research carried out in proposals and projects. All episodes will include an EU funding element, but the key content will be to share the important science findings with the broader public. This first episode has been realized in collaboration with EU Tema. Electric vehicle battery research and innovation plays a key part in the European ambitions to become more and more self-sustainable when it comes to new technologies that we become more and more reliant upon. Especially reliance on components from China represents a practical and strategic challenge in a more and more unstable world. Kristin Fransson is LCA researcher at RISE in Sweden. She's a chemical engineer and has spent most of her career focusing on life cycle assessment analysis within different areas, and recent years specifically within battery research. In this Explain Science episode, we zoom in on the NoVOC project funded by Horizon Europe. She shares the importance of the life cycle assessment and research projects and how EU-funded projects are pushing the area forward. Finally, she resumes the key challenges within LCA in battery research that is highlighted in the paper recently published in connection with the NoVOC project. Before this episode starts, here's a short word from my collaboration partner EU Tema concerning this episode. Please enjoy.
I'm Nicole, and I'm the communication manager of the NoVOC project and a colleague of Kristin's. I work for UTIMA Research Services, which is a small research service provider based in Vienna in Austria, and we're often involved in Horizon Europe projects as communication and project managers and have been guests on Niels' podcasts already quite a few times. Science communication is a really important part of the scientific work today, because scientific progress only has a real impact when people hear about it, when they understand it, and when they can connect it to their everyday lives. And traditionally, scientists communicate mainly through their scientific publications and participation in scientific conferences or discussions with their own research communities. And that, of course, still remains essential. But communicating science to a broader audience through formats like this podcast is becoming increasingly important as well. And so I'd really like to encourage you to follow Niels' new podcast, The Grant, Explain Science. Stay curious and stay tuned for some more of the latest scientific developments.
The Grant. Welcome to The Grant, the EU funding podcast. Today, I am presenting you a new concept, podcast concept. Explain Science. I've had some requests for actual science communication. As my regulars know, as my listeners know, this is an EU funding podcast digging into EU funding elements. But there are also a lot of content. And I've decided to make a series that just keeps rolling. Have it as a regular element in my releases, where I also do actual science communication. But the hook, of course, will be that there is a EU funding element. So all these projects that are being carried out there, they have a space where they can share what they're doing of the important research. And I'm doing this together with EU Tema, which is an old collaboration and contacts of mine, Georg and Nicole, that some of you might remember. They have a couple of projects that we're starting out with. And today, I, of course, have a guest because I don't know anything. I know something about EU funding, but I don't know much about science. Know about something about science when I've been having to force to deal with it. No. Kristin, welcome.
Thank you. It's very nice to be here.
Yeah, thank you for taking a leap of faith and stepping into this together with me and on the lead from Georg and Nicole. Now, Kristin, I'm just gonna let you shortly present yourself before we open up what we're going to talk about today.
Yes, so I'm Kristin. I work at the Swedish Research Institute RISE with life cycle assessments. And I have been working with life cycle assessments both in research and in consultancy for around 15 years. And today my projects are mainly about batteries, metals, and other types of energy storage. So I'm here because of my Horizon projects.
Yeah, but you're also here because you've been now. I've added a quick look at your CV. You've been doing life cycle assessment for your full career, literally. Yeah.
Yeah, more or less. I'm actually a chemical engineer originally, so I have been working a bit as a chemist. And that's good when you do life cycle assessment, that you have some other expertise to lean back on and understand more about the technical parts of the life cycle assessment.
Kristin, we're going to talk about batteries today. The EU funding hook here, it's the NoVOC project, which is a project looking at batteries for electrical vehicles.
Yes, it is.
And we're going to have a conversation about the life cycle assessment part of your work in that project. But can you, in 2 lines, explain what the project is doing?
The main purpose of the project, it's actually in the name, NoVOC. So it's about reducing the hazardous solvent that you use in battery manufacturing and find other solutions that has no VOC, which is like a name for what's hazardous in battery manufacturing. So we look at both dry and wet manufacturing methods that are hopefully better for the environment.
And my best guess, with my experience within EU funding, is that this is a matter of trying to make Europe, make us able to produce car batteries ourselves and make them at the same times cheaper and more sustainable, environmentally speaking. Yeah.
Yes, that's right.
Should we move into the next section about what is life cycle assessment?
Yes, of course. Do you want me to explain something?
Please.
Or do you have any questions? So starting with life cycle assessments, it's a framework or a method to assess environmental impacts. And it's standardized in the ISO system, but you have several options when you do a life cycle assessment. So mainly it's about looking at environmental impact over a product's entire life cycle, starting from raw materials and digging them out of the ground, and over all the production phases, transports, use phase, and finally end of life, how you handle if you recycle or if you incinerate or what you do at end of life.
Mm-hmm.
And if you want, you can look at parts of the life cycle. You often hear terms like cradle to gate. It often means that you look at it from raw material extraction and then you end typically at the production gate. Or you can look at the entire life cycle, and that's often referred to as cradle to grave.
Yeah. And so normally for life cycle assessment in my head, I've always had it like, so this is a 360-degree check if the impact a specific innovation or technology has if you introduce it. Is that, can you say it like that?
Yeah, you can do it. And you can also look at specific parts and so. But what you look at, it's actually part of the framework that you, in the beginning of your study, you decide, what will I assess this time? Like which types of environmental impact? It's not only about climate change, it's also about other environmental challenges like resources and toxicity, water use, and so on.
Yeah. If we try to lean into the battery part, how do you work with life cycle? So what stages of a battery's life is usually considered? So what are you applying when you look into life cycle assessment when it comes to this area?
Yeah, when it comes to batteries, we often look a lot on an EU regulation, the battery regulation, which is in place, and there will be obligations to make a carbon footprint, which is like kind of an LCA, but looking only at climate change. And we have been looking a lot on the draft calculation rules for that. It's not completely finalized yet, but we are inspired by that often when looking at batteries. And in research projects, they are a lot about manufacturing, the ones that we are in. So we typically look much on the manufacturing part, but also on recycling, but maybe not so much on the use phase and what happens there.
Yeah. Towards the end, we will have a look at why it's difficult. So we're going to dig a little bit more into what you're working with, what you're trying to crack in the project. Yeah, I think you gave us a good fly into the life cycle assessment, what that is, sort of getting the terms right. Now, the next section, we're going to have a look at why this is something that matters for Europe. So this is to we're going to reflect on the funding that goes to this and why is it so and why it is important for us. So can you fold that out a little bit?
Yeah, and when you look at the European research projects, they are typically on a like lab scale or pilot scale level. So you don't have the finalized manufacturing routes yet. So you still have some opportunity to make changes. So that's why it's good to have some kind of environmental assessment to make sure that what you do in the project actually leads to a better environment.
Mm-hmm.
And that's why it's important to have life cycle assessment early on in the projects. And we often do it also very, very early in the projects by making a screening LCA to see, okay, what to focus on in this project.
Yeah. You know what? I think the Commission, when it started to put weight on having LCAs in the call text, I think it is related to, of course, like when we fund innovation, when we fund research, it is important for the funding administrator that the consortium behind that is carrying out the activities, that they at least make an effort to make a full life cycle. How can this work? How can this technology work? How it doesn't have a bad influence on something else, or will it crash because something that we didn't think about in this corner? Is it too expensive? Also, like, is it good for the economy or bad for the economy? How is the social? Is it actually polluting something we didn't realize in the first place, but suddenly there's effects in other corners? So I think it's sort of both from the research world, an important element when you enter into something to fold it out, but probably also from a funder's point of view.
Yeah, I think so.
Have you been involved in EU projects on a regular basis? Are you sort of regularly involved in EU projects?
Yes, I mean, another battery projects and then some other energy storage projects as well.
So what's your experience from, has the Commission's, has it changed their view on the LCA part of the projects? Have they adjusted anything, or have the area developed together with the different framework programs evolving? Is there anything you can you remember from the work that you've been doing that it has changed character?
I'm not sure it has changed so much. I've been out of research for some years, and now I'm back again. So my projects now are like at the same place and time. and my old projects were like 10 years ago and a bit out of my mind now to say. But I think that the Commission, they want the LCAs to be there to make sure that environmental impacts are included and given thought in the project. And I'm sure that they are evaluated in some way. What I have been seeing recently is that this safe and sustainability by design is coming more and more, which includes LCA as one of its pillars.
Before we move into to digging into the battery LCA and why it's difficult, I just wanted to understand if your work in EU projects with LCA has that made RISE or your institute or yourself, have you improved your own capacities within like analytical capacities or views and critical mass on how to approach it?
Yes, definitely. I would say in my unit, we are 3 or 4 people working with battery LCAs in Horizon projects. And we have that capacity, and we can discuss together, and we all have a common understanding, and we use more or less the same approach in all Horizon projects. So we can learn from each other and share knowledge and help out quite easy.
Yeah, good. Before we're almost there, I just wanted to check one thing with you. Do you collaborate with other EU projects? So the NoVOC project, do you have an exchange with similar projects also funded?
Yes, I would say that the NoVOC project is a very good example, because the NoVOC project and some other battery projects funded in the same
call.
In the same call and in related call. We have a cooperation called the Battery Heroes.
Yeah.
So we have discussed together in the LCA team or the sustainability teams. Some projects assess other types of sustainability, like social sustainability.
Yeah. So this is exactly where my question is going. If you exchange how they approach the LCA, because I know exactly what you just said, that you also have analysis that includes social parts and economic parts and so on. But so is there? So it's so in other words, you got some. So there's certain critical mass in between, and you can exchange on practices. Or
yeah. So in this battery here, we have had quite a lot of exchange to find out like which methodologies do we use in the different projects, and what are the challenges, and how do we approach the questions. And we can see that some of them, there are quite many similarities between the projects, and of course also some differences. Like in NoVOC, we don't have the social sustainability, but in some of the other projects we have. Most projects have some kind of economic sustainability included.
Okay.
Good. Yeah.
I think the commission, if they listen, they will be so happy to hear this. They love when projects exchange. Kristin, let's move into to geek a little bit on the battery part. So the next section here, we have labeled that why battery LCA is difficult. And we're going to zoom in on the work you do, and you've been doing. So you developed a paper, and we're going to zoom a little bit in on what the findings are. But can you share a little bit about the troubles around this? So what's hard to crack?
Yeah, I mean, there are some things that can be a challenge in all LCAs. You need to do some methodological choices that we maybe don't go into detail on in this podcast, but you have several choices you can make. And an LCA can be correct.
You can try to geek me up. So what choices are we talking about? Can you sort of sum them up?
Yeah, like typically what are the system boundaries? Are you looking at cradle to grave, cradle to gate? Yeah, we talked about that before.
So you set the methodological frame.
Yeah,
And that frame can be set in different. You can put different fences can be moved to the right, to the left, or so on. Yeah?
Yes, and then there's also something called functional unit in an LCA, and that's what you relate everything to.
Yeah.
And in battery LCAs, that can be like 1 kilowatt hour of produced battery capacity.
Yeah.
But you can have other units as well.
So you can turn up and down for these, I guess, and then within the frame, you can say what happens if we turn up for this, what happens within this frame here and here and here.
Yeah, and that's typically something that you can have different in different projects. Another functional unit for batteries can be 1 kilowatt hour of delivered energy over the battery's entire lifetime. And that will give significantly different results than 1 kilowatt hour capacity.
Yeah.
But they are both correct as long as you state it in your goal and scope work in the beginning of the project.
Yeah.
Yeah. So that's the two first challenges.
So the challenge is, what should the frame be, I guess? Yeah?
Yes, and of course, we try to decide that frame within our projects, discussing with the technical partners what's most appropriate. And now we have had lots of discussions on this in the Battery Heroes sustainability cluster.
Mm-hmm.
There are also other types of more difficult methodology that you need to decide on, like for recycled materials.
Yeah.
What burden do you give a recycled materials when you have it as an input?
Uh-huh.
Do you assign any of the primary acquisition of the material, or do you make it like free of burden except for upgrading? And both types are allowed as long as you say how you have done it. But of course, they will give very different results in the end.
Yeah. So in most project phases, the flow and timeline in a project, normally the first part of the project, if it's a technical project like you have here, you have the first phase is often where you look your models. You get your model straight. You have your desktop research. You have collecting in data, whatever. Do you sit down and look at what different types of LC? How do you set different models up to see what would be the likely best model to work with?
I mean, you can do it like that, but we have often you have your favorite way of working and what you think will fit the project best. I think that most researchers have decided before and might make small adjustments.
Yeah. So you have already discussed this in the proposal phase when you were invited into the project, and you had in the researcher corner, you've been having these discussions and exchanges on drawing out the scientific sorts. what should we do here and there? And everybody have their little babies. I know the academic area well enough to know that people are prepared to fight for them to death. But yes, so what you tell me is, which I actually already knew, but I'm also asking open questions here. So this is set when you start.
Not completely set, but we have some kind of boundaries.
Yeah. Can you mention the other challenges that there might be? Why this is difficult? Now you mentioned the definition of the frames, how it affects different things, and then you have the functional unit system boundaries and so on. Is there anything else that makes it? Is there any interconnection with the other activities in the project that can torpedo what you do, or is there anything else you can share?
Yeah, and I think that one of the main challenges in like all LCA projects, it's the data collection.
Yeah.
And it's extra difficult in research projects because in these projects you develop the technology, so you don't have any data from the beginning. You don't have anything to start with. So you need to communicate a lot with the technical work packages and like follow their time frames on when is this innovation, when is this particular process supposed to be finalized in the project, and get the data from that.
Yes, because you also sometimes you would say, 4 years? Is it 4-year project?
I think so.
Yeah, normal for these kind of projects. Certain people say, "Oh, that's a long time." Yeah, but when it comes to research, it's not, because if you need to first set up a system, or if you first need to set up the baseline for how to collect it, then you need to collect the data, and then you need to work with the data. And at the same time, you would have technological development maybe going on in other parts of the project that needs to feed into each other, need to interact, of course. That's why it's a collaboration project. Yeah? And that's what probably you mean, right? That it's
right.
time. It seems long, but it can be tricky for the timeline. For the data
as an example, we will make LCAs for the recycling process in this NoVOC project, and the recycling project part will get the material from the other technical partners when that's ready. So it's a challenge.
And if it's a research project, you cannot just take anything. You need to take things that is connected to the project because it's a lab, so to say. Yeah, it needs to follow the research guide, the frames that you have set up for you to be able to test properly. So I perfectly understand that in the end you'll be squeezed the last year.
Yeah, we will. And the year 2, 3 will be not so much work for us.
Which of course can be frustrating.
Yes, because you want to work continuously and see like what happens if we make those changes and what is. Then another challenge is this about scale.
Yeah.
Because in these better projects, we work like on lab scale or pilot scale in the technical work packages. And that's not the most optimized processes when it comes to energy use, for instance. So it might not be comparable results between research units.
Any researcher and any technological development industry will know exactly what you're talking about. Because it's never the same when you scale up. And that's of course where you have the real world effect of, does this product or approach, is it something that is viable? Is it something that we can be used in the real world? And you can only see that when it's scaled up, but you need to start somewhere.
And of course, in these projects, we're lucky to have industrial partners who can give us a hint of what industrial scale will look like, but you can never really know for sure how it will be.
Thanks. Now let's move into the closing part here. So just a few lines on so the project. You like any other project, there here and there you have events or you have activities where you try to engage with the public or stakeholders or anyone that has an interest in what you're doing. And you have an online event on the 25th of June.
Yes, we have. We have a virtual coffee chat.
Yeah, what's the concept? Can you share?
I think that this coffee chat, it's actually a series of webinars, and it's the first one for the autumn on June 25th.
Mm-hmm.
And we will have a guest, and that's Emanuel Lorenzo from INEGI in Portugal. And that's one of our collaboration partners in Battery Heroes. So he's working in other Horizon projects with LCA.
So the title of that is Charge and Connect, and it's on sustainable lithium-ion battery manufacturing. So you will talk about, is there a specific topic for the June 25 event?
Yeah, and I think the specific topic is about how cross-project collaboration can shape more consistent and robust approaches to battery life cycle assessment.
Aha, that's good. Nice.
Yeah. So I think that Emanuel will talk about our recent paper that has been submitted.
Yes, and let that be 2 lines here. It's very important, because if you have found your way to this podcast, if you have an interest in battery innovation, technology, development here, if you have an interest in life cycle assessment, in what's happening within the area, and if you have an interest in what several EU projects are looking at, the event, yes, but also very much for the report, the paper that you have developed in the project, because that is what we have been sharing, what you have been sharing with us here, some of your findings and reflections from that paper on the LCA part. So there will be, for the podcast episode website that I will set up, There will be links, first and foremost, to you, Kristin, so people can connect with you on LinkedIn. There will be a link to the project website, and then there will be a link to the paper download, and there will be a link to the event, so you can register for that and go and check it out. That was that, Kristin. Thank you so much. Do you have any famous last words before we shut down the conversation?
No, thank you for having me. It was a pleasure to be here.
Wonderful to have you in. Now, dear listeners, I'm not going to have a long exit here. If you like what you're listening to here, there is an Explain Science website. I will also put a link to that. Go and check that out. And then you can also check out the rest of my podcast universe. I have over 200 podcast episodes on EU R&D funding, if that is of your interest. So you can go and browse that out. Thanks, Kristin. Let's say goodbye. Bye.
Bye. Thank you.
Thanks for listening to this first episode of the Grant Explain Science. All the Grant episodes have their own site on the Grant website. You'll find the link in the episode site where you listen to your podcast. On the site for this episode, you'll find lots of information. I have made a specific Explain Science main page, and there you'll also find the link to this specific episode where it has its own site. On that site, there is a link to Kristin's LinkedIn profile and RISE. Further, there are links to the NoVOC project website and, of course, the public webinar mentioned in the episode. And finally, of course, there is also a download link to the LCA paper developed in the project. Next week, I have 2 guests in the studio to exchange and share about the challenges of building up a funding team. You can indeed look forward to that.